Hello guys, welcome to the second podcast of the keyboard of the PC related to PCO subject. I hope you all are good and safe. I had uploaded first podcast of this chapter and you can also find the link of it in description. So let's start the new content of this chapter, and that is key switch design. As you know, that in the first podcast I tell you about the different type of keyboards, and now I'm going to start a new content of this topic, and that is key switch design. So let's start. Several type of switches are used in keyboards today. Most keyboards use one of several variations on a mechanical key switch. A mechanical key switch relies on a mechanical momentary contact type switch to make electrical contact in a circuit. Some high-end keyboard design use a totally different non-mechanical design that relies on capacitive switches. This section discusses these switches and highlights each of the design. The most common type of key switch is mechanical type, available in following variation. First is pure mechanical, second foam element, third is rubber dome, and fourth one is membrane. The pure mechanical type is just that, a simple mechanical switch that features metal contact in a momentary contact arrangement. Often a tactile feedback mechanism consists of a clip and spring arrangement to give a clicky feel to the keyboard and offer some resistance to pressing the key is built in. Mechanical switches are durable, usually have self-cleaning contact, and normally are rated for 20 million keystrokes, which is second only to the capacitive switch. They also offer excellent tactile feedback. Foam element mechanical switches were a very popular design in some older keyboards. These switches are characterized by a foam element within electrical contact on the bottom that is mounted on the bottom of a plunger attached to the key itself. When the switch is pressed down, a foil conductor on the bottom of the foam element closes a circuit on the printed circuit board below. A return spring pushes the key back up. When the pressure is released, the foam dampens the contact, helping to prevent bounce, but unfortunately gives these keyboard a mushy feel. Next one is rubber dome switches. These are mechanical switches that are very similar to the foam element type but are also improved in many ways. Instead of a spring, these switches use a rubber dome that has a carbon button contact on the underside. As you depress a key, the key plunger presses down on the rubber dome, causing it to resist and then collapse all at once, much like the top of an oil can. As the rubber dome collapses, the user feels the tactile feedback and the carbon button makes contact between the circuit board traces below. When the key is released, the rubber dome reforms and pushes the key back upward. The next one is membrane keyboard. Membrane keyboard is a variation on the rubber dome type in which the keys themselves are no longer separate but are formed together in a sheet that sits on the rubber dome sheet. This severely limits key travel, and membrane keyboards are not considered usable for normal touch typing because of this. They are idle in extremely harsh environment. Now we are going to move a new thing, that is capacitive switches. Capacitive switches are the non-mechanical type of switch in use today, as these are the cardiac of key switches. They are much more expensive than the more common mechanical rubber dome, but also are more resistant to dirt and corrosion and offer the highest quality tactile feedback of any type of switches. Basically, the key switch that we read earlier, that is pure mechanical type foam element, rubber dome switch, and membrane keyboard, that all comes under mechanical switches. And only one capacitive switches is only one non-mechanical type switch that we use today. A capacitive switch does not work by making contact between conductors. Instead, two plates, usually made of plastic, are connected in a switch matrix designed to detect changes in capacitance of the circuit. Now, Hall effect switches. These are another type of switch. This is another type of switch which has no mechanical contact. It takes advantage of the deflection of a moving charge by a magnetic field. A reference current is passed through a semiconductor crystal between two opposing faces. When a key is pressed, the crystal is moved through a magnetic field which has its flux line perpendicular to the direction of the current flow the crystal. Actually, it is easier to move a small magnet past the crystal. Moving the crystal through the magnetic field causes a small voltage to be developed between two of the other opposing faces of the crystal. This voltage amplified and used to indicate that a key has been pressed. Hall effect sensors are also used to detect motion in many electrical controlled machines. Hall effect keyboards are able and have typical rated lifetime of 100 million or more keystrokes. The keyboard interface, it is the new content. A keyboard consists of a set of switches mounted on a grid or array called the key matrix. When a switch is pressed, processor in the keyboard itself identifies which key is pressed by identifying which grid location in the matrix shows continuity. The keyboard processor also interprets how long the key is pressed and can even handle multiple keystrokes at the same time. A 16-bit hardware buffer in the keyboard can handle rapid or multiple keystrokes, passing each one in the succession to the system. When you press a key, in most cases the contact actually bounces slightly, meaning that there are several rapid on-off cycles just as the switch makes contact. This is called bounce, and the processor in the keyboard is designed to filter this or debounce the keystroke. The keyboard processor must distinguish bounce from a double key strike actually intended by the keyboard operator. This is fairly easy because the bouncing is much more rapid than a person could simulate by striking a key quickly several times. The processor in the original PC keyboard was an Intel 8048 microcontroller chip, but newer keyboards often use an 8049 version that has built-in ROM or other microcontroller chips compatible with the 8048 or 8049. Let us take an example. IBM has always used a custom version of the Motorola 6805 processor in its enhanced keyboards, which is compatible with the Intel chips. The keyboard's built-in processor reads the key matrix, debounces the key press signals, converts the key press to the appropriate scan code, and transmit the code to the ROM and built-in serial interface. Some other knowledge about keyboards are typematic functions. If a key on the keyboard is held down, it becomes typematic, which means that the keyboard repeatedly sends the key press code to the motherboard. In the 80 style keyboard, the typematic rate is adjustable by sending the keyboard processor the appropriate commands. This is not possible for the earlier PC XT keyboard types because the keyboard interface is not bidirectional. Keyboard mouse interface connectors. Keyboard have a cable available with one of the two primary types of connector at the system, and most aftermarket keyboard have a cable connector inside the keyboard case on the keyboard and require that you open up the keyboard case to disconnect or test. Actual IBM enhanced keyboards use a unique cable assembly that plugs into both the keyboard and the system unit. This makes cable interchange or replacement an easy plug-in affair. a special connector called an SDL, and the full form of SDL is shielded data link, that is used on the keyboard end, and the appropriate DIN, which means Dusky industry norm. I repeat, Dusky industry norm connector at the PC end. Some other information about DIN and SDL. DIN, that I have already told you, the full form of it is Dusky industry norm, and the spell of the Dusky is DEUTSCHE industry norm. norm, a committee that sets a German dimensional standard. It is a German industrial norm or a committee that sets a German dimensional standards. And about STL, as also about this I have already told, shielded data link, a type of shielded connector created by AMP and used by IBM and other for keyboard cables. So I hope you understand this podcast very carefully. After this I'm going to uploading a new podcast or podcast 3 on this chapter, or to complete this chapter, keyboard of the PC. So thank you so much for listening it.